We can construct confidence intervals and prediction intervals for a new value, say, of x equals x naught, so a new observed value. And so once you plug that into the regression model, you would then get a y hat, and that is the expected value of y. So we would have here expected value of y. So this is the confidence interval right here, the first one. It is a confidence interval for the expected value of y, or average y, given x equals x naught. And that x naught goes right into the formula here. So you would have y hat, that's our estimate, plus or minus the margin of error. And the margin of error has the critical value t of alpha over 2, multiplied by the standard deviation of the error, S sub e, we know that well now, and then multiply that by the square root of 1 over n, where n is the number of observations, add that to our new value, x naught, and subtract the average of the x's, square it, and then divide that by the sum of the squares for the x's. That is our confidence interval for the expected value of y given a value x equals x naught. So the second one here, this second one is not a confidence interval, it is a prediction interval. We call it a prediction interval because if we have a new value given a new observation, x naught, we can then plug that into the regression and get y hat. But instead of predicting the average y, we can just predict a single y. And so because we're predicting what y would be, not the average y, but a single y, we have to have this value 1. It comes with elaborate proofs that we won't go into in this course, but if you compare the confidence interval with the prediction interval, the only difference is this number 1 right here. So this is a wider interval. The prediction intervals are wider because if you think about it, it makes sense. We're only predicting a single y, whereas here we're predicting what the average would be for the confidence interval. So to look at that, I'm using our online sales example again with our 5 customers. So along the vertical, we have our sales. Along the horizontal, we have our independent variable time in minutes for the online, using the online chat feature. And the blue line was our y hat. That was y hat. And it equaled, what did it equal? A slope of 0.519 times x, plus it had an intercept of 70, I believe it was 75.222, something like that, our intercept. So it would be about there. 75 would be about right here. And the slope is 0.519. So that is our y hat. The green would be the dotted green there would be our confidence bands. So if I gave a new value, say 90, that would be a new x, an x naught equals, say, 90. Then we could look and we would go, okay, the confidence band would be between this value and this value. So any of those values would be the expected value of y. If we were to do a prediction interval given x naught equals, say, 90, then the prediction interval would be the orange dashed lines, and they'll be wider because of that 1 under the radicand, underneath the radical. So that would go from this minimum value to this maximum value. Okay, so we can do an example. Let's see if we can do an example here. And let's use x equals 90, like I had mentioned. So we can plug that in. So y hat would equal our intercept 75.222 plus our intercept, or our slope 0.519 multiplied by 90, we get a y hat of $121.93. Okay, so we can then construct a confidence interval for that given value of x naught equals 90. So it's a new value. Actually, I don't want to have equals yet. I want to have plus or minus the margin of error, which is going to be a t of alpha over 2 multiplied by the SE multiplied by 1 over n plus that was going to be x naught subtract the average x's. We have all these values. We just simply need to plug them in. So the y hat we got here was $121.93 plus or minus a t. We'll make this a 95% confidence interval. We seem to have the same theme. And that ended up, if you look on the table, we've done this already for our previous confidence intervals for the slope, a t of 0.025 on 4 degrees of freedom gives us 2.776. You can verify that with the table. Our standard error, standard deviation of the estimate was 4.38. Multiply by 1 over 5 customers, plus our new value is 90. Subtract our average x's was 62. Square that, divided by 4480 was the sum of the squares of our x's. Finish that off. We can keep going here. That would be 121.93 plus or minus our margin of error. If you plug all that in, you should get, and be very careful plugging it in. I might go one more step here. So that would be, and these are multiplied by 4.38 multiplied by 1 over 5 plus 784. You might want to do this because this gets tricky going into the calculator accurately. That ends up being $121.93, $121.93 plus or minus $7.446. So that ends up being, let's put dollars here, $114.48. So this is the confidence interval for a new response, 129.38, right? And I'm rounding here, and I think that's an 8. And so we have here $114.48 to $129.38 would be a confidence interval for y hat, the expected value of y, given a new value x equals x naught. In this case, it was 90.